Chapter 4: Energy and the Future. So we all know that there will be a problem of energy in future, and also there is a problem. Already you can see that we have the crisis and the possible reasons for the energy problem. The first reason could be the expanding world's population. So in the earlier years, or when you look at your parents or grandparents' ages, if you are aware of, then you know that maybe there was one car per household. But now we see that everyone in the household has a car as long as they are eligible to drive the car. So you can see that a lot of people are using cars, or they are trying to use as many possible luxuries as possible, using ACs and airplanes and transportation things and so on and so forth. And the other problem is a decline in fossil fuel supply. So we have set aside fossil fuels available, and if we keep using it, one day we will run out of them. The third reason is global warming due to the greenhouse gases. So there is a severe threat to the all around the world that these greenhouse gases are increasing, which are threatening the temperature levels and other related issues in the world. So these are some reasons for the energy problems. When you look at the graph, which shows that from year 1600 to 2100 projected, of course, you can see that it's always been increasing. The population is always been increasing, but you can see that from 1900 it's kind of increasing exponentially. So if the same trends keep on going, and looking at the growth of the population, you can see that about 10 to 12 billion people will be there end of 21st century. So the world's population is increasing from this graph. Currently, about 85% of the world's energy is produced from fossil fuels. When you look at the fossil fuels, which are covered in this 85% right here in the circle, these fossil fuels cover coal, oil, natural gas. And rest of the 15% energy which the world is using coming from either nuclear or other renewable sources such as solar, wind, or hydroelectric. So these fossil fuels, we have only so much left. Though it is abundant at this time, but if we keep using it, then at some point we will run out of all those sources. So we have to put more emphasis in increasing the natural resources or the renewable energy sources, where we could produce more energy rather than getting into a situation of running out of all these sources. If the current trend continues as expected, the fuels also need to continue to increase. So you can see that the population was increasing from the 1960s pattern when you look 1600 patterns when you looked at it. So it has been increasing. So the consumption of these fuel supplies also has been increasing. So as you can see that it is increasing, and all this oil, coal and gas which are more used, they're also increasing, but you can see that they are increasing at a much faster level compared to what it used to be at a slower pace. Global warming. So you always talk about global warming. So let's see what actually the global warming is. The symptoms of increased temperature. So the increase in the surface and the air temperature. So what happens if the temperature around us increases? We all know that the whole world on the earth, it is almost 3/4 is water and 1/4 is land. So we have lots of ice glaciers. So let's imagine the temperatures keep on increasing and these ice glaciers melt. What happens? All the sea levels and the ocean levels water will increase. So what if if there is an increase in the levels of sea levels or ocean levels? So at some point they will overflow. So once they overflow, they will cover the whole entire world. So that is the problem. So that is why we are worried about the temperature increases, because that is the direct effect of increased temperature patterns. So it would diminish the volume of glacier ice and it would make the higher sea levels. All these have consequences on the weather patterns too. Average global surface temperatures. Historically, the surface temperature of the planet has shown various variations in the temperature. So the temperature's variation is not a new thing. As you can see in this graph from year 1000, we have seen these fluctuations every year. But why are we worried about this fluctuation now? Because you can see that the fluctuations were plus or minus 0.5. But when you look at about 2000, you can see that the fluctuation is only towards the increment, and also that increment is going at a very high levels, that which is making us feel that it's going to increase a lot and it's going to be um, cautious. So we are already aware that the temperatures are increasing. So let's see what if it keeps on increasing, what happens. So optimistic look. If no further population growth is followed, no further population growth, and also followed by a decline in the carbon dioxide emission, then there is a possibility that there will be a small increase in the global temperature, which would be around 1 degree to 2.9 degrees Celsius every year. So when we look at the population, we make sure that there is no population increase, and also we make sure that the carbon dioxide emission is declined. Then still there will be a global temperature increase, but that would be around the ranges of 1 to 2.9 or 3 degrees Celsius. Pessimistic look at it, that is, if the same trends continue, carbon dioxide emissions continue to increase, then more dramatic increase in temperature, which would be about like 3 degrees Celsius to 7 degrees Celsius temperatures, could be increased, and this will be too much. So in about 10 to 15 years, the outside temperatures would be about like 150 Fahrenheit to 160 Fahrenheit. That will be too much. So that is why people are trying to bring more awareness on controlling the population growth and also the carbon dioxide emission, less carbon dioxide emission to the atmosphere. So we have been talking about having less carbon dioxide emission and so on and so forth. So let's see what actually is the connection between the carbon dioxide and to the whole weather patterns around the earth. So the role of infrared radiation. So the infrared light is absorbed by several gaseous components of the atmosphere. So we know that the atmosphere has many gases such as oxygen, carbon dioxide, carbon monoxide, nitrous oxide, and so on and so forth. So majority of it is in those gases, carbon dioxide is the one which could absorb this infrared radiation. So whenever the sunlight falls on the earth, some of it would be reflected and some of it would be absorbed by the earth. And at some point, whatever the energy was absorbed, it will be released back to the earth, released back to the sun. So that is the natural tendency, that some of it will be absorbed and it will be released. But whatever is coming from sun, if it is not projected back, then it is a problem. This carbon dioxide, what it does is whenever it is reflected back to the sun, some of the infrared radiation is absorbed by this carbon dioxide. Not only that, whenever the earth is releasing whatever it absorbed earlier, that also is absorbed by the carbon dioxide. So this infrared radiation is nothing but it is kind of heating up the whole entire air which is surrounding the earth. So that is the problem. So which is not letting the heat get out of this atmosphere. So that is the problem. So as the earth emits IR, which is infrared radiation, this energy is also trapped by the gases in the atmosphere. As the carbon dioxide percentage in the atmosphere increases, more heat is trapped. It means more temperatures, high temperatures on the earth. Evidence of the rise in carbon dioxide. So how did we figure out that there is an increase in the carbon dioxide emission? Analysis of air bubble trapped in ice. They did some experiment in Greenland and the Antarctic, which indicates that the current carbon dioxide levels are 27% higher than they have been in the past 650,000 years. Though we might look like it is a long back, but 30% increase is a huge increase. It is thought to be primarily to the increase of the carbon dioxide or carbon-based fuels. So most of the fuels which we use are the carbon-based fuels. So anything we burn to get the energy out would release the carbon dioxide or carbon monoxide or carbon byproducts. So obviously that is increasing the content in the atmosphere. So when you look at the countries where there is highest industrialized nations, when you look at it, that you can see that the United States is at the top right here, next to Russia and Japan and some of the countries like third world war countries. They are right here, which are less in the industrialized nations. You can see that America is somewhere at the top. So, presence of carbon dioxide in atmosphere. Increased fossil fuel use has increased the concentration of the carbon dioxide in the atmosphere. So we keep on using these carbon-based fuels. It is increasing the carbon dioxide emission into the atmosphere. As you can see in this graph right here, it has been increasing from the beginning, but you can see that the more industrialization made it much worse. Other greenhouse gases. So we have been talking about the greenhouse gases, and as the name indicates, the greenhouse gases, it's supposed to be good gases because it says greenhouse gases. It's not called red or any other color, but they are called greenhouse gases because they are good for the earth in some way. That is the trees which keep the earth green, they need this carbon dioxide to survive. So that is why we call them greenhouse gases. Okay, so but the problem is we are making the carbon dioxide content more than the trees which inhale that carbon dioxide. That is the problem. Okay, so some of the other greenhouse gases are methane, CFCs and HCFCs, nitrous oxide. As you can see right here, most of it is carbon dioxide.